Hello guys, so in this video we will be going to discuss the difference in between AWS SNS simple notification service, AWS SQS simple queue service and AWS IoT Core. Okay, so we will be going to understand one by one and then we will decide we will understand where we can use which service, right? So first of all, I think all the three services are, I think, mainly from the same perspective. Like it basically creates and bridge in between publishers and consumers. Okay, so let's say you have some messages and you wanted to send those messages to some different services. In that case, those three services can be used, either SNS, either SQS, or either IoT Core. Okay, so let's understand this scenario for SNS, simple notification service. Okay, so let's say I think once we placed an order on Amazon, Amazon have different perspective of that order, right? First of all, they wanted to notify you on your email. They wanted to notify you on your SMS, like mobile number. Then after they will going to notify to the seller as well, like this order has been created. Then after they are going to notify the courier or the freight company to pick this order from the seller, right? So there are multiple things or multiple tasks they have to perform. Okay, so in that scenario, what they are going to do once the order has been placed, right? So then after a message would be published, so from where the message has been published, they are, we will call them as a publisher, right? So publisher service. Okay, so once I think message once the order has been placed, they are going to publish a message on the SNS topic. Okay, on that SNS topic, this SNS topic would be responsible for sending the same data to different consumer. The first one is for sending on user's email, for sending on user's mobile number, for sending on the freight company, for sending to the seller, right? So those four things would be it has to do. So kind of we would be going to have four consumers and all the four consumers would be notified by this SNS topic only, like this message data, this data has been come, this message has been come, this message has been come, and also this message has been come. Okay, so but there is one issue. Let's say due to some error or maybe due to some, I think, service down, either like out of those four, two is down, right? Or maybe any one of them are down. So in that case, that message would be lost. Okay, so there is no message storage in SNS. Okay, so I have written here as well, there is no persistent storage. It is like, my bad. So once it receives the message, it is going to deliver to all those consumers. Okay, so that's the important point. SNS is kind of delivering message to your consumers. Okay, so that's where we are going to use SNS. So I think I have just listed down some of the consumers, like it would be a Lambda function, some email service or SMS service, SQS, one and all of those things. Okay, so we will understand this in detail, like why we have SQS inside the consumers of SNS, right? We will understand it detail. So let's understand SQS first. So SQS is basically simple queue service. Okay, so the major difference I wanted to highlight is, first of all, it has some persistent storage, that is from 1 minute, like 1 minute to 14 days it can be configured from the console. Okay, so here we are trying to say like message would be stored inside this queue only, right? Then after the, if you observe, like here the arrow points like from SNS to consumers, but here if you see, the arrow points like from consumer to SQS queue. Okay, the change is basically in the SNS is going to deliver message to different consumers, but here consumers are going to read data from SQS queue. Okay, SQS will not deliver message. Consumer would read the message from SQS queue, and once they have executed this message successfully, they are kind of going to acknowledge this message on the SQS queue, so that SQS know like this message has been executed successfully. Okay, so then after SQS is going to delete this, right? So let's understand where we can use SQS. Okay, so let's say we like, let's take an example of YouTube only. So on YouTube, I think different creators are uploading their videos, right? But in the backend, maybe let's say thousands of videos are coming per second, but in the backend they don't have the capability or capacity to execute or to fetch out the captions or to generate the captions for all videos in a single time, right? So what they are going to do, once a video has been uploaded, what they will do, they will going to publish a message with video ID, video path, like where the video is stored, and in which language we have to generate the captions, right? Then after, maybe we would be having consumers, let's say four or thousands of the consumers who will read data from this SQS queue and process those videos and generate the captions, right? So all the consumers would have multiple same tasks, right? But if you see, like in the runtime, quite possible the number of consumers that we have is not able to process the messages, right? So let's say we have 100 consumers and millions of videos are coming, right? So a single consumer or maybe all those consumers can't process all those videos in a single time, right? They want to queue, right? So once this first message is consumed, let's pick second is done, third pick, right? So that this is the use case we want as an SQS. Okay, so I think that's one more point I wanted to highlight. If you see, SNS is basically like fan out architecture. So fan out is like one message published and you wanted to send it to the multiple consumers, right? So in those cases, uh, SNS we are going to use. But let's say uh, kind of we don't want to deliver, the consumer is going to read from SQS queue. That's the difference, right? Now let's understand how we can utilize both of them, SNS and SQS, to perform or to utilize it better in our project, right? So the issue is, if you see, let's again understand. Okay, so we placed an order and thousands of order are coming on this SNS topic, and thousands of those messages would be sent to this email service only. Just send an email, send an email, send an email. But this service don't have that capability to execute millions of messages at a time, right? So what we are going to do, we can place an queue here in between SNS and this consumer service that will store the all the message, and then after consumer would be responsible for reading data from that queue, and then after process message, right? So let's understand this flow only, right? So we have publisher are publishing message continuously on SNS. Using SNS, we basically fan out those three single message to three different personas or three different services for three different tasks, and each of them have their individual queues, and then after this those services would be reading data from this queue and then after executing it. Okay, so that would be the, I think, the use case for SNS SQS. I hope you got the difference, right? Then after, let's understand why we need AWS IoT Core. Okay, so AWS IoT Core, if I tell you in brief, it is more or less, near or less similar to SNS in working, right? But if you see, like I don't know if you know or not, but Mosquito is an open source broker, like which is equivalent to AWS IoT Core only. So it's a broker basically. So let's say you have multiple devices. Okay, so I think you know very well, today we have smart ACs, right? Smart bulbs, smart fan, everything is smart in today's, right? In the today's time. So all those lights or maybe fan or everything is going to publish data on the cloud, and then after we are going to store it in the DynamoDB table or in the XYZ table in the database, right? The current state of all those lights, right? So let's say a building have thousands of the devices, and all those devices current state would be required on the cloud applications, right? So in those scenario, those light devices would be sending data in a very small size, like state on and off. This is really a data in less than bytes, right? So in those scenarios, what we can utilize is, we can utilize this AWS IoT Core. The beauty is AWS IoT Core we basically use when the message size is very small, right? The size is very small and data is coming on a fast frequency, right? So that's the one first use case. Second is, inside the SNS, the issue is we have to create topic statically. Okay, so let's say we wanted to like kind of process anything, right? So we have to create a fixed topic, go to the AWS IoT console, create a topic, let's say order, and then after create consumers, right? But inside the AWS IoT Core, the advantage is we don't have to create topic manually. It is just like device want to push and data to XYZ topic, this device just send the XYZ topic data, and then it would be the responsibility of subscriber to subscribe data on the same topic on which publisher is publishing or this device is publishing. Okay, so then after this, on this XYZ topic, device, this application may be subscribed from the AWS IoT Core. So AWS IoT Core just behaving like a server only. Lights or maybe the XYZ devices would send the data to AWS IoT Core, or here application would subscribe data to AWS IoT Core. We don't have to create topic statically here, so dynamically device can choose any topic whichever they want, and subscriber will going to listen on that same topic. Okay, so I think in the SNS we have to define manually those are the consumers, or but here I think we can just create any number of consumer from the Python script. That would be the advantage. Then after, I think IoT Core out of the box provide an rule engine as well. So once any message would be received, what this rule engine can do, rule engine can basically ingest that message to different services. So for example, to SNS, SQS, maybe directly to DynamoDB, maybe directly to AWS S3. So that would be the advantage of IoT uh, uh, like rule engine only. Okay, so one thing I wanted to highlight is, again, let's say this device sends some message and your subscriber or maybe the consumer is not awake or maybe not working. In that case, that message would be lost. It don't have any persistent data storage. Okay, so that's the important point. This AWS IoT Core don't have any persistent data storage. It is similar to SNS. The only difference is dynamic topic. Okay, so I think that's it for this video. I hope you're very clear with this SNS, SQS, and IoT Core. If you have any queries or comment, do post it down in the comment section. Or if it helps, keep subscribe to the channel. Thank you.